In this lesson, we continue to work through the full-face helmet model. We're going to start with the ridges on the back of the helmet. This was another boundary surface feature. The thing to remember about the boundary surface is that it works best if it's a four-sided surface as the result. Now, the first surface we created was not four-sided. It was technically only two sides. If we roll this back and have a look, the first side would be this side that goes all the way around, and the second side would be the. Now, this does cause a slight problem, which we may run into later on. It's called a degeneracy, and by using the face curves feature, you can select a face, and if all of the face curves come to a point, this is what's known as a degeneracy. It's basically a zero-length side, and it happens when you create a feature where all of the sketches coincide at a single point on the part. When you have a side, mathematics does not like zero very much, and CAD models don't like zero very much. So this will cause us a problem that we will see later on, and there are a couple of ways of dealing with it, which we'll take a look at. Let's continue for the time being and look at creating these ridges in the back. The trim, the ridge cutout, is set up so that we will have four sides. This will be a direction 1, and then a direction 2 will close off this gap, and another direction 2 is on this side. So rolling down the feature, the first way this was created, if we roll back the sketch, so created a sketch in here that had 3 arcs, 2 of them tangent on each side, and then 1 in between, just to make the ridges in a 2D sketch. And to make the ridges blend into the rest of the surface, that's where the boundary surface comes in. If we edit the feature, I'll turn off these curvature combs. They often get. Notice that these ridges start to diminish, and then by the time you reach this other side, they're completely gone. Let's make this selection from scratch. I'm going to start with this edge as a direction 1 and this edge as another direction 1. SOLIDWORKS gives us a preview, but we need to make both of these edges curvature to face. What this does is it ensures that the curvature of the new face that's created is the same as the curvature on the other side of the edge, which gives us a very smooth model. We won't see an interruption in the smoothness as it goes across this edge. Direction 2 on one side will be our sketch, and on the other side, this angled line. At the angled line, we're going to set that curvature to face, and at the sketch, we're going to set this normal to profile, so that as the shape crosses the plane of symmetry, the shape is smooth. Okay, so that's all there is to setting up the boundary surface for this particular feature. A trim, a sketch, and a boundary surface gives us this nice cosmetic feature on the back of the helmet. If you needed more control over the shape or direction of these ridges, you could have added a secondary profile, or we could have used connectors. Let's take a look at the use of connectors to control these ridges. Click on the sketch, I can add a connector, and SOLIDWORKS shows me where it would come naturally on the other side. I can pull this down, or I can push it up. And you see the effect that has on the finished surface. If I want to control the other ridge as well, I'll add another connector and see how this affects the shape. Now notice in areas like this, where you see the surface kind of doubling up on itself, if I were to click the green check right now, get an error or an ugly looking area on the surface. Sometimes if you're pushing connectors too hard, the surfaces will buckle or ripple or do things like this, so you need to watch out for those. The error that you will get when SOLIDWORKS gives you an error rather than just bad geometry will be that the surface is self-intersecting. We can spread these out or bring them closer together. But you see, as we start to get more radical in the changes, you can see that it's starting to a little bit. So let's pull this down. And that buckling is gone. Okay, let's rename this surface Cosmetic Ridges. And then continue to roll back a couple of features. First, I have an offset. And if we take a look at this offset, we can see one of the problems that we had mentioned earlier. I'm going to set this to use edges for the display. Let's edit this offset took the main surface of the helmet and it offset it to the inside by 0.1 inches. Now, if we take a look at this closely, we can see right in here that there's a little notch taken out of the surface. Let's look at this again with the face curves function. This little notch is directly above the 0 point of the initial surface. And if we get the face curves of the offset in the original, we see that that's exactly what's happened. The curvature around the degenerate point is often suspect. There's often a little bit of a problem with it. And so when you offset it, especially when you offset it to the inside, SOLIDWORKS typically has a problem with that. If you were to shell out a part like this or to try to thicken it later on, or even sometimes putting a fillet over this 0 point, the degenerate point, SOLIDWORKS could fail, or it could just tell you that you've got bad geometry in your part. You have to when you're dealing with surface models, because it can prevent you from moving forward on a project. Okay, let's exit out of the face curves feature here. What we're doing next is creating a mouth vent, and we're going to use this offset surface to help us get there.